Hey champs of Examsnet, welcome to the question series of Examsnet. Students, you must have explored our website www.examsnet.com. This site is a great place for you to practice your entrance exam question papers because here you will find so many entrance exam question papers along with their detailed PDF solutions, and you must download our app. The link is available in the description box for the better preparation of your exam. So today students we will be solving JEE Main 2024 9th April shift 1 paper. Okay, so in this particular video I'll be solving the physics part of the paper. So starting with the very first question of this physics series, that is question number 31. It says that a proton, an electron and an alpha particle have the same energies. Their de Broglie wavelengths will be compared as. Okay, so first of all, champs, this question is from the chapter of modern physics. Okay, we have to find the de Broglie wavelength of these proton, electron and an alpha particle. Okay, so we know that the de Broglie wavelength can be written as lambda equals to h over p, where h is the Planck's constant and p is the momentum of the particle. So so for a proton and for an electron and alpha particle, it will be can be written as h over, okay, momentum can be written as under root of 2m into kinetic energy k. Okay, since we know that kinetic energy is what, p square by 2m. Okay, so we can write p square equals to 2m into kinetic energy. So p is equals to under root of 2mk. That's why we have written under root of 2mk in place of p. Okay, so from here we see that the de Broglie wavelength is directly proportional to 1 over under root of m. Okay, so it depends on the mass of the particle. So as we know that in case of proton, electron and alpha particle, uh, electron is having the uh, minimum less mass. Okay, we can say less mass. Least mass is of electron. Then after that, uh, we have proton, and after that we have alpha particle. Okay, so least mass means greater wavelength, and highest mass means maximum mass means least de Broglie wavelength. Okay, so in case of this, we will have lambda of E will be greater from all of them, then lambda of proton, and then at last lambda of alpha particle. Means alpha particle is having the least wavelength since it is having maximum mass, and then proton, since it is having the mass between electron and alpha particle, so its wavelength lies between electron and alpha particle, and the electron is having least mass. So for least mass less means wavelength is higher, so electron is having the maximum wavelength. So the correct option among these four option is option B, that is wavelength of electron is greater than the wavelength of proton, and it is greater than wavelength of alpha particle. Okay, now next question. A particle moving in a straight line covers half the distance with speed 6 meter per second. The other half is covered in two equal intervals with speed 9 meter per second and 15 meter per second respectively. The average speed of the particle during the motion is. Okay, so this question is from the chapter of kinematics. Okay, we have a particle which is moving along a straight line. Let us say this is a straight line. Okay, and it covers half the distance with 6 meter per second. Let us give the distance some points A, B. Okay, let us say this is C and this is D. Okay, let us say AB distance is covering in time T1, and BC is T, let us say, and CD is also T. Okay, so the distance between them is S and S. Okay, so particle is covering half the distance with 6 meter per second. 6 meter per second. Okay, we have given the displacement as between B and D. So BD will be equals to S, and it will be equals to from the question, it is saying that the other half is covered in two equal time interval with 9 meter per second and 15 meter per second. Means from B to C, it is taking, it is moving with a speed of 9 meter per second, and from C to D, it is moving with a speed of 15 meter second, and from A to B, it is moving with a speed of 6 meter per second. Okay, so BD will be, so the total distance S will be 9 into T, okay, plus 15 into T, okay. Since we know that distance equals to X equals to V into delta T, na? So speed into T. So BD, for BD, covering the distance between B and D, BD, the displacement, or we can then say that the total distance, not displacement, the total distance will be equals to 90 plus 15T. So it will be equals to 24T. Okay, and between AB, it is equals to S will be equals to 60, na 6 meter per second. So 61, let us say. Okay, so it will be equals to, so comparing now, and question is saying that one half is covered with a speed of 6 meter per second, and the other half is covered with in two equal time intervals, 9 meter per second to 15 meter per second, the average speed of the particle during the motion. Okay, so for finding the time T1, let us equate this because they are equal halves. Na? So AB will be equals to BC plus CD means BD. So AB will be equals to CD, sorry, BD. So it will be 24T will be equals to 61. Okay, from here 6 goes to 24. So we see that T1 is equals to 40. Okay, let us say this is equation 1. Since we know that speed is what? Speed equals to distance over time, distance over time. So speed will be equals to, total distance will be equals to this, total distance will be equals to 48T. Okay, over how 48T? Since this is 24T na, and we and this is 61, and we have find that T1 equals to 40. So 61 means 6 into 4, T equals to 24T. So this 24T plus this 24T means total distance is 48T from A to D. The total distance is 48T over time. Time is something like that. This is T1, this is T and T. T and T means 2T plus T1. So it will become 2T plus T1. Okay, so it will be equals to 48T over 2T, and from here T1 is 40 na. So it will be equals to, speed will be equals to 48T over 60. TT cancels, 6 8 is 48. So speed is equals to 8 meter per second. Okay, so the average speed of the particle is 8 meter per second, means the correct answer is option D. Now, next question 33. A plane electromagnetic wave is propagating along X direction. Okay. Along X direction, is it has a wavelength of 4 millimeter. If the electric field is in Y direction, electric field is in Y direction with the maximum magnitude of 60 volt per meter, then the equation for magnetic field is. Okay. So this question is from the chapter of electromagnetic waves. Electromagnetic waves. We have to find the magnitude of the magnetic field, means equation for magnetic field. Okay, champs, we know that relation between electric field and magnetic field is E equals to BC. Okay, E, the magnitude of E is given as 60 equals to B. We have to find B into C. C is 3 into 10 to the power 8 meter per second. So from here, B is equals to 60 over 3 into 10 to the power 8. So B will be equals to, from here, B is equals to 20 into 10 to the power minus 8, means B is equals to 2 into 10 to the power minus 7. Okay. And we have to find the equation for magnetic field. Na? So we can write the equation as, okay, we also know that C is equals to F into lambda. Okay, C is 3 into 10 to the power 8 meter per second equals to F into lambda. Now, lambda is, wavelength is 4 millimeter, na? So it will be 4 into 10 to the power minus 3 meter. So from here, we see that F is equals to 3 into 10 to the power 8 over 4 into 10 to the power minus 3. So it will become, F will be equals to 3 by 4 into 10 to the power 8 plus 3, 11. Okay. Now, For this, if we want to find the angular velocity omega, we know that angular velocity omega equals to 2 pi f. So it will be 2 pi into f. Frequency is 3 by 4 into 10 to the power 11. 2 2s are 4. So it will be equals to 3 by 2 pi into 10 to the power 11 omega. Okay. Omega is 3 by 2 pi into 10 to the power 11. So okay, correct. So since given in the question, electric field is in y direction and the propagation is in x direction. So the magnetic field will be in the positive z direction. Okay. So for this, the correct equation is magnetic field B. Magnitude is for this B is equals to 2 into 10 to the power minus 7. B means magnitude is 2 into 10 to the power minus 7 sine kx minus omega t. Omega t means omega is this 3 by 2 pi into 10 to the power 11. And if we are taking pi by 2 common from here, so it will be uh minus 3 into 10 to the power 8 kt. Yeah, the second option is the correct answer. Okay. Since the equation can be written as B is equals to B naught sine kx minus omega t. Na? So just put the values here. B naught is 2 into 10 to the power minus 7 sine kx. K is the wave vector. It is equals to 2 pi over lambda. So for k, we can write 2 pi over lambda. Lambda is 4 millimeter. Now 4 millimeter means 4 into 10 to the power minus 3 meter. So it will be k equals to pi by 2 into 10 to the power 3. So pi by 2 into 10 to the power 3, this is kx minus omega t. So omega is this 3 by 2 pi into 10 to the power 11. So 8 plus 3 is also 11 and 3 pi by 2. Yeah, so the correct answer is option B. Now 34th question, given below are two statements. Statement 1. When an object is placed at the center of a curvature of a concave lens, image is formed at the center of curvature of the lens on the other side. And second statement is concave lens always form a virtual and erect image. Okay. So we have to choose the correct answer from these four options. So first of all, this question is from the chapter of optics. Okay. So it is saying that when an object is placed at the center of a curvature of a concave lens, the image is formed at the center of curvature of the lens on the other side. Okay. So first of all, we know that the formula is 1 over V minus 1 over U equals to 1 over F. Okay. If object is placed at the center of curvature, means in place of U, we will write minus 1 over minus of 2F. So it will be equals to 1 over minus of F. Okay. So it will be 1 over V is equals to this will be 1 over minus 1 over F. This will become plus and again this will become minus 1 over 2F. So 1 over V will be equals to 2F minus of 2 minus of 1. So 1 over V will be equals to this minus of 3 over 2F. So minus of 3 or okay, it will become minus minus plus now. If here it is plus, so when it will go here, it will become minus. Oh, so sorry, this is plus. Okay, sorry, this is plus, this is plus. So this will be plus 2. So it will be plus 1. So okay, so 1 over V equals to plus of plus 1 now. Yes, 1 over V equals to 1 over 2F. So from here we see that V is equals to 2F now. So 1 over V equals to 1 over U plus 1 over F. It is if it is like this, so it is forming a virtual image or of real object. So the statement second, that a concave lens always form a virtual and erect image. So this statement is wrong, as it is forming a virtual or real image, not virtual image. Okay. So so the statement so from this statement 1 is true, but statement second is false, according to me. No, sorry, statement 1 is also false. V is equals to 2F, na? And it is saying that the image is formed at the center of curvature of the lens. So it is not forming at the center of curvature of the lens. So this first statement is also false. And second statement is also false. So according to me, the answer second, that is both statement 1 and statement 2 are false. Okay. Now next question 35. A light emitting diode LED is fabricated using GaAs, gallium arsenic semiconducting material whose band gap is 1.42 electron volt. The wavelength of the light emitted from the LED is, okay. So this question is from the chapter of semiconductor devices. Semiconductor devices, okay. We have to find the wavelength of the light emitted from the LED. We know that the formula for wavelength lambda is equals to 1240 over this E in terms of electron volt. It is equals to 1240 over 1.42. Solving it, we get 875 nanometer. It is very simple question, just formula based question. Okay, so the correct answer is 875 nanometer, means option C. Now, 36th question. A sphere of relative density sigma and diameter d has concentric cavity of diameter d. The ratio of d by d if it just floats on water in a tank is, okay. So this question is something like buoyancy force, from the topic of buoyancy force, okay. So according to this question, let us say this is the water and something sphere is floating on it, okay. If the sphere is floating on it, it is exerting a force, downward force mg in the downward direction, and upthrust force fb, which is the buoyancy force. So this fb will be equals to rho vg, density into volume into gravity. So for making the sphere to float on this water, so this downward force must be equals to this upthrust force fb. So this is m mass. So writing mass in terms of density and volume. So we can write in place of mass, we can write density into volume V into G, and it is equals to rho, let us say this volume V dash into G gravity. So G cancels out each other. Since it is the in question, it is saying relative density, okay. So when we divide this density with the density rho of the buoyancy force which is acting in the upward direction, so this density divided by this rho will be equals to sigma. So sigma into volume is 4/3 pi r cube. Now it is saying that it is having a diameter d and a concentric cavity of diameter d. So we have diameter d, and here we have to write r cube. Now r cube means in place of here we will write r is equals to half of the diameter. Na? So here we will write d cube over 8 minus of d cube over 8. Okay. Pi r cube na here. So d cube over 8 minus d cube over 8, and it will be equals to density. Density here, it goes down. That's why it is making sigma, and V volume is 4/3 pi d cube over 8. Okay. Now 4/3 pi cancels out each other. So sigma d cube over 8 minus d cube over 8 will be equals to d cube over 8, taking 8 1/8 common. So 8 cancels out each other. So we get sigma d cube minus d cube is equals to d cube. So now taking d cube common from here, so we get sigma d cube is equals to 1 minus d cube over d cube in equals to d cube. So this d cube cancels out. So we get sigma 1 minus d cube over d cube is equals to 1. So from here we can write 1 minus d cube over d cube. It is equals to 1 over sigma. Okay. And we have to find the ratio of d over d, capital D over D. Na? So for capital D over D, we can write like this. 1 minus 1 over sigma will be equals to this d over d whole cube. Okay. So taking LCM, sigma minus 1 over sigma will be equals to this d over d whole cube. Okay. Now we can write this d capital D because we have to find the ratio of capital D over small d. Now, so for capital D over small d whole cube will be equals to this sigma over sigma minus 1. So d over d will be equals to sigma over sigma minus 1 raised to the power 1 by 3. This is our final answer. So the ratio of capital D over D is sigma over sigma minus 1 raised to the power 1 by 3, means option A is the correct answer. Now 37th question. A capacitor is made up of a flat plate of area A and a second plate having a stair-like structure as shown in the figure. If the area of each stair is A by 3 and the height is D, the capacitance of the arrangement is, okay. So this question is from the chapter of electrostatic potential and capacitance. Potential and capacitance, okay. Now, the question can be solved like, let us say, it is made up of flat plate of area A and a second plate having a staircase-like structure. Let us say this is the flat plate, it is having an area A, and second plate is having a stair-like structure. Like, let us say this is second plate, it is having a stair-like structure, and let us say the distance between them is D. Okay, this is D. And area of each stair is A by 3. According to question, each stair is of area A by 3 and this distance is D. So means this height is D. So the capacitance of the arrangement is, okay. So for this, we can solve it like this. We can solve it like this. All capacitors, these all capacitors, they are in parallel. So these parallel combination, na? And we know that for parallel combination, total capacitance C is equals to C1 plus C2 plus C3. Let us say the first stair is having a capacitance C1, the second stair is having a capacitance of C2, and the third stair is having a capacitance of C3. Okay. So for parallel capacitance, parallel combination, sorry, we can write C equivalent is equals to C1 plus C2 plus C3. And we know that capacitance C is equals to epsilon naught A over D. Okay, so we can write it as C equivalent is equals to epsilon naught A over D, means D plus D plus D, 3D for first capacitance, plus epsilon naught A over 3 into 2D, okay, 3 into 2D plus epsilon naught A over 3 into 3D, okay. So solving it, we get C equivalent is equals to epsilon naught A over 3 D. It will be equals to 1 plus 1 over 2 plus 1 over 3. So solving it, we get C equivalent is equals to epsilon naught A over 3D. 6 plus 2 3s are 6, 3 2s are 6. So we get C equivalent is equals to epsilon naught A over 3D. 69 plus 2, 11 over 6. Okay. So C equivalent, we get it as 6 3s are 18, 11 epsilon naught A over 18 D. This is our final answer. So capacitance of this system is 11 epsilon naught A over 18 D, means option A. Now next question 38. A light unstretchable string passing over a smooth light pulley connects two blocks of masses m1 and m2. If the acceleration of the system is z by 8, then the ratio of the masses m2 over m1 is, okay. So we have to find the ratio of the masses of m2 over m1. Na? So for such kind of system, smooth light pulley system, which is connecting two blocks m1 and m2. Let us say this is m1 and let us say this is m2. Okay. So we can write A of whole system, means acceleration of the whole system is m2 minus m1 over m2 plus m1 into G. This is the formula. And according to question, it is given as G by 8. So it is equals to G by 8. So this G cancels out. So we get M2 minus M1 over M2 plus M1 is equals to 1 over 8. Now solving it, we get 8M2 minus 8M1 over M2 plus M1 equals to 1. So it will be equals to 8M2 minus 8M1 equals to M1 plus M2. So 8M2 minus M2 is equals to M1 plus 8M1. So solving it, we get 7M2 equals to 9M1. So M2 over M1, it is equals to 9 over 7. So the ratio of M2 over M1 is 9:7, means option A is the correct answer. Now 39th question, the dimensional formula of latent heat is, okay. So this question is from the chapter of units and measurements. Units and measurements, okay. So latent heat is what? It is a specific heat. So for specific heat, it is equals to mL2 T minus 2 over mass M. So just solve it, we get M naught because it will cancels out each other. L2 into T minus 2. So the dimension of latent heat, which is actually the specific heat, is M naught L2 T minus 2. M naught L2 T minus 2, means option C is the correct answer. Now 40th question, the volume of an ideal gas, the adiabatic constant it given as gamma equals to 1.5 is changed adiabatically from 5 liters to 4 liter. The ratio of the initial pressure to final pressure is. This question is from the chapter of thermodynamics. Okay, and we know that for an adiabatic process, P1 V1 is equals to, P1 V1 gamma is equals to P2 V2 gamma. P2 V2 gamma, okay. So P1 and changing from 5 liters to 4 liters. So yani V1 is 5 liters into gamma. Gamma is given as 1.5. It is equals to P2. V2 is 4 liter and the gamma is 1.5. So ratio of initial pressure to final means P1 over P2 is equals to 4 over 5 raised to the power 1.5 means 3 by 2. So solving it, we get 4 over 5 into 4 over 5 raised to the power 1 by 2. So it will become 8 over 5 root 5. Okay. So the ratio of initial pressure to final pressure is 8 over 5 root 5, means option C is the correct answer. Now next question is 41. The energy equivalent of 1 gram of substance is, okay. So we know that the formula for energy and mass relation is given as E equals to mc square. Okay, so E will be equals to mc square, means the mass is of 1 gram. So 1 into 10 to the power minus 3 kg into c square, means 3 into 10 to the power 8 meter per second whole square. So it will be in terms of joule. So it is equals to 10 to the power minus 3 into this 9 into 10 to the power 16, and converting this joule into electron volt means divide it with 1 over 1.6 into 10 to the power minus 19. So it will become equals to 6.241 into 10 to the power 18. Okay, so E will be equals to 56.169 into 10 to the power 31 electron volt. So we can write E equivalent to 5.6 into 10 to the power 26 mega electron volt. Okay. So our answer is E is equals to 5.6 into 10 to the power 26 mega electron volt, means option D is the correct answer. Now next question 42. An astronaut takes a ball of mass m from Earth to space. He throws the ball into a circular orbit about Earth at an altitude of 318.5 km. From Earth's surface to the orbit, the change in total mechanical energy of the ball is this. Okay, so we have to find the value of x here. So this question is from the chapter of gravitation. Okay. So in this question, we are given altitude means height h is equals to 318.5. It means we are given our radius of Earth, okay, uh, divided by 20. Okay. So total energy will be equals to, we know that it is equals to minus gmm over re. So gme mass of Earth into m over radius of Earth. So total energy will be, let us say this is the initial energy and this one is the final energy. So it will be equals to minus G MEM over 2RE plus H, means the altitude height at which we have to find this. Okay. So it will be equals to minus GMEM over 2RE, and height will be RE over 20 as according to the question. Okay. Now, uh, this will become, final energy will become minus G ME M over this 220 RE plus RE, it will be 21 RE over 20. So it will be 2 times the 20, and this 10 will come here in the numerator. So total energy final will be equals to minus of 10 GME into M over 21 RE. Okay. So what we have to find, we have to find the total change in the total mechanical energy of the ball. So change in the total mechanical energy will be final minus initial. Okay, so it will be equals to, final is minus 10 G M E M over 21 RE, and the initial is this minus G M E M over RE minus G, this minus minus will become plus, so it will be GMEM over RE. Okay. So taking common GMEM over RE, so we get 1 minus 10 over 21. So it will be equals to this 21 minus 10, it will be 11. So it will become 11 GMEM over 21 RE. So comparing it with that given in the question, X GMEM over 21 RE. So the value of X is here. Comparing it with this given in the question, so the value of X here is 11. Okay. So among the four option A, that is 11, is the correct answer. Okay. Now question 43, given below are two statements. Statement 1 is, when currents vary with time, Newton's third law is valid only if momentum carried by the electromagnetic field is taken into account. And statement 2 is, Ampere's circular law does not depend on the Biot-Savart's law. Okay. So this question is something like conceptual one. So the correct answer is statement 1 is true, but the statement 2 is false. Okay, the option B is the correct answer. Now, 44th question. A particle of mass m moves on a straight line with its velocity increasing with distance, and according to the equation v equals to alpha under root of x, where a is a constant. So, where alpha is a constant. The total work done by all the forces applied on the particle during its displacement from x equals to 0 to x equals to d will be. Okay. So, this question is from the chapter of kinematics. Okay. We are given with v equals to alpha under root of x. So, displacement in from x equals to 0 to x equals to d. So, when x equals to 0, v will become 0. Okay. And when x equals to d, v will become alpha root d. Okay. So the work done will be equals to final kinetic energy minus initial kinetic energy. Okay. So we know that kinetic energy is half mv squared. The final will be half mv is alpha root d whole square minus half m v square. V is 0. So 0 square, it will become 0 eventually. So the work done will be equals to this 1 by 2 m alpha square into d. So the answer is m alpha square d by 2, means the correct answer is option C, m alpha square d by 2. Now 45th question. A galvanometer has a coil of resistance 200 ohm with a full scale deflection at 20 microampere. The value of resistance to be added to use it as an ammeter of range 0 to 20 milliampere is. Okay. So this question is from the chapter of current electricity. Okay, so we are given with a galvanometer having resistance 200 ohm. So G is 200 ohm here, and current is given as deflection at 220 microampere. Okay, so we know that the relation for the galvanometer I is equals to Ig G over S plus 1. This is the direct formula. Okay, so Ig is given as 20 microampere, means sorry, current is given as 20 microampere na. Okay, Ig 20 into 10 to the power minus 6 into G over S. G is given as 200. We have to find the value of resistance to be added to use it as an resistor. Okay, 200 over S plus 1, and current is range is from 0 to 20 milliampere, means the current is given as 20 milliampere. So 20 into 10 to the power minus 3. So solving it, we get this 20 cancels out, 10 to the power minus 3. So it will be 10 to the power minus 3 over 10 to the power minus 6. It will be equals to 200 over S plus 1. So this will be equals to 10 to the minus 3 plus 6 equals to 200 over S plus 1. This will be 10 to the power 3 uh, equals to 200 plus S over S plus 1. So 200 over S will be equals to 1000 minus 1. So 200 over S will be 999. So S will be equals to 200 over 999, means it is equal to approximately 0.2 ohm. Okay, so the resistance is 0.2 ohm, means option B is the correct answer. Now 46th question. A heavy iron bar of weight W is having its one end on the ground and other end on the shoulder of a person. The bar makes an angle theta with the horizontal. The weight experienced by the person is. Okay, so this question is from the chapter of kinematics only. So let us try to understand this question as, let us say, according to it, there is a heavy iron bar of weight W. Okay, let us say this is weight of W, and it's one end on the ground. This is the ground, and other end on the shoulder of a person. Let us say this is the person, and its one end is on the shoulder of the person. Okay, the bar makes an angle theta with the horizontal. It is making an angle theta with the horizontal. The weight experienced by the person is. Okay, so if this is angle theta, so there will be a force Ng in the upward direction, and there will be force R in the upward direction. Okay, where R is the net force, net reaction force by the shoulder is giving a reaction force now, so it will be the reaction force. Okay, balancing the torque about point of contact on the ground. So W L by 2, this cos theta, it will be equals to this R into L cos theta. Okay, so from here we see that cos theta L cancels out, so we get R is equals to W by 2. So the weight experienced by the person is W by 2, means option A is the correct answer. Now 47 question. One main scale division of a vernier caliper is equal to m units. If nth division of main scale coincides with n plus 1th division of vernier scale, the least count of the vernier caliper is. Okay, so this question is from the chapter of units and measurements. Units and measurements. Okay, so we are given one main scale division of a vernier caliper is equals to m units. And if nth division of main scale coincide with n plus 1th division of vernier scale, means nth of main scale coincide with n plus 1 of vernier scale division. Okay, so one vernier scale division will be equals to n over n plus 1 main scale division, and we know that least count is one main scale division minus one vernier scale division na. So here the least count will become 1 MSD means this will be M minus M units na. So that's why we have written M minus M into 1 VSD is N over N plus 1 MSD. So solving it, we get least count is equals to M, taking M common, so it will be 1 minus N over N plus 1. Okay, now solving it, we get M N plus 1 minus N over N plus 1. So this N cancels out. So we get least count as M over N plus 1. So this is the final answer. Least count is M over N plus 1. So the correct answer is option B, M over N plus 1. Now 48th question. A bulb and a capacitor are connected in series across an AC supply. The dielectric is then placed between the plates of the capacitor. The glow of the bulb. Okay. So this question is from the chapter of current electricity. We have to find the correct answer, whether the glow of the bulb increases, decreases, remains same, or it becomes equals to 0. Okay. So first of all, let us draw this question as this is the capacitor, this is the resistance R, and this is the alternating source. Okay. A bulb and a capacitor are connected in series. Okay. These are connected in series across a AC supply. A dielectric is then placed between the plates of the capacitor. If dielectric is placed in between the capacitor, the glow of the bulb is okay. First of all, we know that Z is equals to what? Under root of R square plus XC square. This we all know. And we know that XC is what? 1 over omega C. So if uh, when the dielectric is placed between the plate of a capacitor, so if the C increases, this means XC decreases. If capacitance increases, so XC decreases. So if XC decreases, means Z decreases. Okay. So Z decreases. So if Z decreases, so the current increases and the bulb will glow more brighter. So the correct answer is for option A. Okay, XC is equals to 1 over omega C, na, inversely proportional to C. So if C increases, XC decreases. If XC decreases, this Z impedance also decreases. So if it decreases, the current will increase. Now, if current will increase, so the glow of the bulb will also increases. Okay. So next question 49. The equivalent resistance between A and B is okay. In this question, we are not given with the figure. So let us first draw the figure as the figure is something like this. This is of 6 ohm. This is of 10 ohm. And here one resistor of resistance 5 ohm. It is connected like this. And here it is of 8 ohm. This is point A. This is B. And this is of 4 ohm. This is of 11 ohm. And this is of 8 ohm, and this resistor is of resistance 7 ohm. Okay, so we have to find the equivalent resistance between A and B. So first of all, let us try to redraw this is current circuit diagram as this one is 6 ohm and this one is 10 ohm. Okay, this is 8 and this is 4, this is 5 and this is 7. So if we redraw this, we can write it as, see, these two are in series, these two are in series, but these and these two are in parallel, and these combination are in parallel. So using parallel and series combination for resistances, we get this one is as 15 ohm and this one is also 15 ohm. Okay, and this will become of 15 ohm. And now this one is of 8 ohm. This is point B and this is point A. This will become of 6 ohm. Okay, using parallel and series combinations for this resistances. Okay, so again these three are in parallel, so using parallel combination means 1 over R equivalent equals to 1 over R1 plus 1 over R2 plus 1 over R3. So for these three parallel combination, we will get this 5 ohm, this is 8 ohm, and this is of 6 ohm. This is point C, okay, and this is point D, and this is point B, and this is point A. Now these three are in series, so for series combination we will use R1 plus R2 plus R3. So using this we get R equivalent is equals to 6 plus 5 plus 8 ohm. So this will comes out to be 19 ohm. So our final result is 19 ohm, means option D is the correct answer. Now, 50th question. A sample of 1 mole gas at temperature T is adiabatically expanded to double its volume. If adiabatic constant for the gas is gamma equals to 3 by 2, then the work done by the gas in the process is, okay. So this question is from the chapter of thermodynamics. Thermodynamics, okay. So we know that for an adiabatic expansion, TV gamma minus 1 is equals to constant, okay. So here gamma is 3 by 2, adiabatic constant. So TV 3 by 2 minus 1, it will be equals to, initial will be equals to the final. Na? So final is TF. Volume is becoming double. So 2V 3 by 2 minus 1. So this will be TV 3 by 2 minus 1 means 1 by 2. It will be equals to TF 2, 3 by 2 minus 1, 1 by 2 into V1 by 2. Okay. So this V1 by 2, V1 by 2 cancels out each other. So we get TF is equals to T over root 2. Okay. Let us say this is equation number 1. Now we have to find the work done by the gas in the process. So work done will be equals to this formula we know, NR delta T over 1 minus gamma. So it will be equals to N, number of mole, 1 mole. So value of N will be 1 into R into delta T. Delta T is final minus initial. Final is T over root 2 and initial is T over 1 minus gamma. Gamma is 3 by 2 as given in the question. So work done will be equals to, this will become R. This will be taking T common. So we get 1 over root 2 minus 1. And here we get 2 minus 3. It means minus 1 by 2. So this will become work done is equals to, this 2 will go in the numerator and multiplying it with minus sign. So we get 2RT 1 minus 1 by root 2. Okay. So taking its LCM now. So we get 2RT root 2 minus 1 over root 2. So work done will become root 2 RT root 2 minus 1. Okay, so this is our final answer. Root 2 RT, root 2 RT root 2 minus 1. Okay, it is not matching with the given option. So what we have to do? So this is 2RT 1 minus root 2 na. So if we take 2 inside here, so work done will be equals to something like this, RT 2 minus 2 by root 2. So it will become work done equals to RT 2 minus root 2. Okay. Work done is RT 2 minus root 2. So from here, option A, RT 2 minus root 2 is the correct answer. Okay. So next question is 51. If A and B makes an angle cos inverse 5 by 9 with each other, then modulus of A plus B is equals to root 2 modulus of A minus B. For modulus of A equals to N modulus of B. The integer of N is, okay. So this question is from the chapter of kinematics. So we have to find the value of N here. Okay. So we are given cos inverse 5 by 9 means cos theta is equals to 5 by 9. Okay. And we know that for cos theta, we can write A dot B dot product. Na? So for cos theta, we can write A dot B. We can write A dot B over AB equals to 5 by 9. Now, since we know that for sine theta we use dot cross product, and for cos theta we always use dot product. Okay, so a dot b over ab equals to 5 by 9 over ab equals to 5 by 9. Okay, and we are given that modulus of a plus b is equals to root 2 a minus b. Okay, so from here a plus b means resultant of this will be equals to a square plus b square plus 2a dot b. Okay, and resultant of this means it will be equals to 2a square plus 2b square minus 4a dot b. Okay, so solving it we get 2a square plus 2b square, here a square plus b square, and 2ab minus 4ab, so it will come here, so it will become 6ab. It will be equals to a square plus b square. Okay, and a dot b, from here this ab is equals to 6a dot b is equals to a square plus b square na, and from here we can write ab is equals to 5 by 9 ab, a dot b equals to, so in place of this we can write 6 5 by 9 ab is equals to a square plus b square. Okay, so it will be 3 2s are 6, 3 3s are 9, to means 10 over 3 ab will be equals to a square plus b square. Okay, and in this question, we are given that A equals to NB. So just write A equals to NB means 10 by 3, A equals to NB, and B square is equals to N square, B square plus B square. Okay, so it will become 10 NB square equals to 3N square, B square plus 3B square. So this will be like 3n square b square plus 3b square minus of 10 and b square is equals to 0. Taking b square common, so we get 3n square plus 3 minus of 10 n is equals to 0. So this is like a quadratic equation. To solving it, we will get 3n square minus 10n plus 3 equals to 0. So we can write it as 3n square minus 9n. 3 3s are 9, so minus 9n minus 9 plus 3, it will be equals to 0. So 3n, it will be equals to n minus 3. And here we can take minus of 1. So it will be n minus 3 again. Okay, so 3n minus 1 is one factor and minus 3 is another factor. So from here we see that n equals to 1 by 3 and n equals to 3. Okay, so we have to take the integer value. So for this, n equals to 3 is the correct answer. Okay, n equals to 3 equals to correct answer. Now next question 52. At the center of a half ring of radius r equals to 10 centimeter and x pi v, the value of x is. Okay, so this question is from the chapter of kinematics, but I think the question is incomplete. Okay, since it is asking to find the value of x and we are given only with the center, at the center of a half ring, the radius is r equals to 10 centimeter and x pi v. What is x pi v? So I think this is not the correct question. Okay, not correct question. The question number 52, it says that at the center of a half ring of radius r equals to 10 centimeter and linear charge density 4 nanocoulomb per meter, the potential is x pi volt. So we have to find the value of x. Okay, so this question is from the chapter of electrostatic potential and capacitances. Potential and capacitance. So in this question, we are given a half ring, okay, and its radius is given as 10 centimeter and linear charge density. Linear charge density means lambda. Linear charge density is equals to total charge over
its length. Let us say L be the length. So we can write lambda equals to total charge Q over, and it is of half ring give and the radius of it's given as R. So we can write in place of L, we can write it as pi R. Okay, so from here we can write charge Q is equals to lambda pi R. Now we know that the potential for a half ring is equals to 1 over 4 pi epsilon naught charge over radius, and this 1 over 4 pi epsilon naught we can write it as constant K, and the value of K is 9 into 10 to the power 9. So we can write potential V as K Q over R. And from this equation, let us say this is equation number 1. From equation number 1, we can write Q as lambda pi R. So just substitute lambda pi R in place of Q. So we can write V is equals to K lambda pi R over R. So cancelling out R from numerator and denominator, we get potential V is equals to K lambda pi. Since K is 9 into 10 to the power 9 and lambda is linear charge density is given as 4 nanocoulomb per meter. Nanocoulomb means 4 into 10 to the power minus 9 and pi. So putting the value of pi, okay, just remain it at pi only because we have to find the answer in terms of pi volt. Na? So multiplying it, we get V is equals to 9 fours 36 into 10 to the power 9 minus 9 into pi, this become 1. So we get V equals to 36 pi. So comparing it with that given in the question, that is x pi V, x pi volt equals to x pi. So the value of x here 36. So this is our final answer, that the value of x as asked in the question is 36.
Now next question is 53. A star has 100% helium composition. It starts to convert 3,4He into 112C via triple alpha process. As this process, the mass of the star is this 2 into 10 to the power 32 kg, and it generates energy at the rate of 5.808 into 10 to the power 30 watt. The rate of converting these 4 helium to 12 carbon is n into 10 to the power 42 per second. So we have to find the value of n. Okay. So this question is from the chapter of atomic and nuclear physics. Atomic and nuclear physics. Okay. So in this question, we are given the alpha process as 4He plus 4He plus 4He. Triple alpha process gives 12 carbon plus Q. Okay. So in this case, the power generated will be equals to N over T into Q. Okay. Where N equals to N naught of the reaction per second. Okay. N is the number of reaction per second. Okay. This N is the number of reaction per second. So Q will be equals to this energy liberated or generated. It is equals to 3 mass of helium minus mass of carbon. Reactants minus product na into C square MC square na. So delta MC square. So Q will be equals to 3 into mass of helium. Mass of helium is 4.0026 U. 4.0026 minus mass of carbon is given as 12 U. 12 into C square means 3 into 10 to the power 8 whole square. So Q is equals to, solving it, we get 7.266 mega electron volt. Okay. So in this question, we are asked to find the rate of converting these. So rate means N over T is equals to power over Q. Okay, so power is what? Power is given as 5.808 10 to the power 30 watt. 5.808 into 10 to the power 30 watt over Q. We have find the Q is 7.266 mega electron volt means 10 to the power 6, and electron volt means converting it into joule 1.6 into 10 to the power minus 19. So N over T will be equals to, solving it, we get 5 into 10 to the power 42. So the rate of conversion of 4 helium into 12 carbon, rate of conversion will be equals to this 5 into 10 to the power, actually it will be 15, not 5. 15 into 10 to the power 42. So the value of n is here 15, okay? So the value of n is 15 here. Now next question 54. In a Young's double slit experiment, the intensity at a point is 1/4 of the maximum intensity. The minimum distance of the point from the central maxima is, okay? So this question is from the chapter of wave optics. Okay. In Young's double slit experiment, okay, the formula for the intensity we all know in Young's double slit experiment, that is I is equals to I naught cos square delta phi by 2. Okay, so it is changing 1/4, means this will be I naught by 4. Okay, so it will be equals to I naught cos square delta phi by 2. So this I naught cancels out. So we get delta phi will be equals to, okay, this will be cos square delta phi by 2 will be equals to 1/4. So here this delta phi will be equals to 2 pi by 3. Okay, and we know the formula for the maximum, central maximum is 2 pi over lambda yd over capital D, where D is the width of the slit and capital D is the distance between the slit and the screen. Okay, so yd over D is equals to, from here delta phi means 2 pi by 3. So solving it we get 2 pi cancels out. So we get y is equals to lambda d, sorry, lambda small d. Okay, y is equals to capital D, lambda d over d into this 3. Okay, so it will be equals to wavelength lambda is given as 600 nanometer, d is 1 millimeter and capital D is 1 meter. 600 nanometer means 600 into 10 to the power minus 9. Capital D is 1 meter and D is 3 millimeter, means 3 into 1 millimeter, sorry, not 3. 1 millimeter, 1 into 10 to the power minus 3 into this 3. So it will be equals to 3 2s are 6, 200. So this will be 2 into 10 to the power minus 9 plus 2 plus 3. So y will be equals to 2 into 10 to the power 3 to 5 minus 9 minus 4. Okay. So the minimum distance will be y equals to 2 into 10 to the power minus 4 meters. Okay, this is our final answer. Now next question 55. A string is wrapped around the rim of a wheel of moment of inertia 0.40 kg meter square and radius is 10 centimeter. The wheel is free to rotate about its axis. Initially the wheel is at rest. The string is now pulled by a force of 40 Newton. The angular velocity of the wheel after 10 seconds is x radian per second. So we have to find the rate value of x. So this question can be solved as, we know that tau is equals to f into r, f cross r, or we can write fr. Okay, and this is equals to I into alpha. Okay, so it will be equals to, moment of inertia is given as 0.40 kg meter square. Okay, so, and radius is given as 10 centimeter. So it will be equals to 40 into 0.1. It will be equals to 0.4 alpha. Okay, and alpha is equals to here 10 radian per second now. This f40 into r 0.1 in terms of meter, it is equals to I 0.4 into alpha. So alpha will be here 40 into 0.1 over this 0.4. So solving it, we get alpha as 10 radian per second square. So the angular velocity of the wheel, angular velocity will be this 10 into this 10 second. It will be equals to 100 radian per second. Okay, this is the answer. Now next question is 56. A square loop of S length 2 meter carrying current of 2 ampere is placed with its edges parallel to XY axis. A magnetic field is passing through the xy plane and expressed as B equals to B naught 1 plus 4x k cap, where B naught equals to 5 Tesla. The net magnetic force experienced by the loop is okay. So this question is from the chapter of magnetic effects of current and magnetism. Magnetic effects of current and magnetism. Okay. Now, this is something xy plane, and according to question, we are given a square loop whose edge means length is 2 meter, and current flowing in the circuit is of 2 ampere current. I is 2 ampere current. Okay. This F1 force, let us say, is acting in this direction, and F2 force is acting in this direction. Okay. This is the center of this. So this point is according to coordinates. This one will be x equals to 0 point, and this is of x equals to 2 point. Okay. So as given in the equation, magnetic field passing through xy plane and expressed as B equals to B naught 1 plus 4x k cap, where B naught equals to 5 Tesla. So magnetic field at x equals to 0 is given as B naught, and magnetic field at x equals to 2 will be B naught 1 plus 2. 4 2s are 8. So it means 9 B naught. Okay. So it will be 9 B naught. So, and also we know that force F is equals to I L into B. Okay. So from here, F1 will be equals to I L and B naught F1. Okay. And F2 will be equals to I L and 9 B naught. Okay, let us say this is equation second. So F will be equals to, magnetic force will be equals to F2 minus F1, change in the force. So it will be 9 IL B naught minus IL B naught. It will be equals to 8 IL B naught. Okay. So 8I, current is 2, length is also 2, and B naught is given as 5 Tesla. So just put the value here, 8 into 2 into 2 into 5. It will be 40 into 4, so it will be 160 Newton. The force will be 160 Newton here, okay? 160 Newton. Now, 57 question. Two persons pull a wire towards themselves. Each person exerts a force of 200 Newton on the wire. Young's modulus of the material of the wire is given as this. Original length of the wire is this, and the area of cross section is this. The wire will extend in the length. Okay, so we have to find the elongation in the length, that is delta L. So for this, we know that force over area is equals to Young's modulus into elongation in length over original length. We have to find the elongation in length. So delta L will be equals to F into L over A, area into Young's modulus Y. So delta L will be force. Force is given as 200 Newton. So 200 into original length is given as 2 meter over area is given as 2 centimeter square, means 2 into 10 to the power minus 4 into Young's modulus is given as this, y into 10 to the power 11. Sorry, 1 into 10 to the power 11. So just solve it and we'll get a desired answer. Delta L will be equals to 2 cancels. This will be 2 into 10 to the power 2 plus 4 minus 11. So it will become delta L is equals to 2 into 4, 5, 6 minus 11, 10 to the power minus 5, means it is 20 micrometers. So elongation in length delta L is 20 micrometer. Okay. Now next question 58. When a coil is connected across 20 volt DC supply, it draws a current of 5 ampere. When it is connected across 20 volt 50 hertz AC supply, it draws a current of 4 ampere. The self-induction of the inductance of the coil is. So this question is from the chapter of electromagnetic induction. Electromagnetic induction, okay? So we have to find the self-inductance, okay? So let us draw this case as this is LR, okay? This is volt. This is of 20 volt and the current is of 5 ampere, okay? Let us take the case of first. When this 20 volt DC supply and current is 5 ampere, okay? So we know that V equals to IR. So from here, R is equals to V over I. So V over I means V is 20 volt, I is 5 volt. So R will be equals to 4 ohm. Okay, let us say this is first. Now take the second case. For second case, let us draw it like this. And this is something like this. For second case, the supply is of 20 volt and frequency is 50 hertz. Okay. So this will be 20 volt comma 50 hertz and current is at previous 5 ampere. So for this current I will be equals to again V equals to IR. Okay. So from here I is equals to V over R. V is 20 and for this we have to find the value of Z. So we know that this is what a current is of 4 ampere now, not 5 ampere. Current is 4 ampere. Yeah. So I is equals to 20 over this Z. So I is 4 ampere equals to 20 over Z is under root of R square plus XL square. Okay, since it is inductance also na XL required. So this will be equals to 4 5 is 20. So 5 is equals to under root of R square plus XL square. So squaring both sides, we get R square plus XL square equals to 25. So R is 4 ohm. Now we have already calculated R as 4 ohm. Uh, yeah, R is 4. So just put the value 4 square plus XL square equals to 25. So XL square equals to 25 minus 16. XL square equals to 9. So XL is 3 here, 3 ohm. So the value of L will be this XL over 2 pi F. So L will be equals to this 3 over 2 pi F means it is equals to 3 over 2 into pi into F. Frequency is given as 50 hertz. 50. So it will be equals to okay, value of pi. As given in the question, take the value of pi as 3. So 3 over 2 into 3 into 50. This 3 cancels out. So L is equals to 1 over 2 into 50 means L is equals to in terms of we have to find the answer in terms of millihertz, millihenry na. So for this L will be equals to 1 over 100. So if we put here 1000, so it will come in terms of millihenry. So L will be equals to 10 millihenry. Okay. So the correct answer is L equals to 10 millihenry. Now 59. The position, velocity, and acceleration of a particle executing simple harmonic motion are found to have magnitudes of 4 meter, 2 meter per second, and 16 meter per second square. Means position, velocity, and acceleration. The amplitude of the motion is root x meter, where the value of x is. Okay. So for this, position is given as 4 meter, velocity is given as 2 meter per second, acceleration is given as 16 meter per second square. So amplitude will be equals to omega square into x. Okay. So root x meter, the amplitude is given as root x meter. Okay. Okay, amplitude is given as root x meter. So A will be equals to omega square x and A is given as 16 meter square. So 16 will be equals to omega square into x into 4. So omega square will be equals to 4. 4 is a 16. Okay. So omega will be equals to 2 radian per second. Okay. So from here, velocity will be equals to omega under root of this a square minus x square. So amplitude A will be equals to under root of v square over omega square plus of x square. So A will be equals to velocity is given as 4. No, sorry, velocity is given as 2. So 2 square is 4 over omega. We have find value of omega as 2. So omega square means 4 plus x. X is given as 4. So 4 into 4, 16. So A amplitude will be equals to 1 plus 16 means amplitude is equals to under root of 17 meter. Okay. So our answer is 17 meter. Now next question 60. The current flowing through the 1 ohm resistor is N over N. N over 10, we have to find the value of N. So we are not given with the circuit diagram. So first let us draw the circuit diagram. This is of 4 ohm. This is point B. This is point A. This is of 10 volt. And I1 is current flowing through it. This is of 1 ohm. This is point B. This is of 2 ohm. This is point C. This is again of 2 ohm. And this is of 4 ohm. This is point D. Okay. And here is 5 volt. This is point E. Okay. So we have to find the current flowing through 1 ohm is N by 10. So we have to find the value of N here. Okay. So uh, N by 10, the value of N is, okay, this is 5 volt now. So let us put the value here in place of B. Let us, sorry, this is must be point A, not B, because B is here. Okay. Let us say this is point XV. Okay. And this is point E. So for point E, and this is point B now. If we put X volt here, and in place of C, if we put Y volt here, so, and here it will be 5 volt from because of this. So B will be equals to 5 volt, and this will be of 0. D will be of 0 volt. Okay, because here the voltage difference is 5 volt now. So if this is 5 volt, this must be 0 volt. And we have put A as X volt and C as Y volt. So for this, we can write this Y minus 5 over 2 plus this Y minus 0 over 2 plus this Y minus X plus 10 over this one. This must be equals to 0 now. So we can write this Y minus 5 over 2. This will be equals to Y minus 0 over this 2 plus this Y minus X plus 10 over 1. Y minus X plus 10 over 1 will be equals to 0. Okay. So this, solving it, we get this Y minus 5 plus Y plus of this 2Y taking LCM minus of 2x plus of 20, it will be equals to 0. So solving it, we get y to y means 4y minus 2x plus of 15 is equals to 0. Let us say this is equation number 1. Now for this x, so x minus this 5 over this 4 plus x minus 0 over this 4 plus x minus 10 minus y over this 1 must be equals to 0. So what we have to write, x minus 5 over 4 plus x minus 0 over this 4 plus x minus 10 minus y over this 1 plus x minus 10 minus y over 1 will be equals to 0. So again taking LCM, x minus 5 plus x plus 4x minus 40 minus 4y will be equals to 0. So simplifying it, we get 4x plus x, 6x minus of 4y minus of 45. It will be equals to 0. So we can write if we, okay, so we have to find the register is n by 10. Okay, we have to find the value of n. This is equation 1 and this is equation, let us say 2. 6x minus 4y minus 45. Okay, so if we find the value of, okay, just use these two equation and simplify them. 4y minus 2x plus 15 equals to 0. 6x minus 4y minus 45 equals to 0. Okay, so multiply this equation with 3. Okay, if you multiply this equation 3, it will be minus of 6x plus 12y. Here 45 is equals to 0 and this will be 6x minus 4y minus 45 is equals to 0. So just add them, we get, this will cancel out. So we get 8y is equals to 0, means y equals to 0. Now this value of y, put this value of y in any of the equation. Let us say put in equation number 1. So we get 0 minus 2x plus 15 equals to 0. So 15 equals to 2x. So x will be equals to 15 by 2. So we get y equals to 0 and x equals to 15 by 2. So the current in this circuit will be equals to I will be equals to this y minus x plus of 10 over 1, because we have to find through resistor 1 ohm. So I will be equals to y is 0 minus x is 15 by 2, means 7.5 plus 10 over 1. So I will be equals to 2.5 ampere. So comparing it with that given in the question, n by 10. So this will be equals to I will be equals to 2.5 ampere equals to n by 10, means n is equals to 25 ampere. Sorry, n, not current. N is equals to 25. So the value of n here, 25.